So I want to talk to you about parabolas. Now, the parabola is the name that we give the shape that is formed when we graph a quadratic equation. When we graph a linear equation, that shape is called a line, and we graph a quadratic equation, that shape is called a parabola. The parabola is the graph of a quadratic equation. And when I say quadratic equation, and I'm saying graph, what I'm implying is that I have an equal sign with y on one side and with a quadratic expression on the other side. Or if I'm feeling in, a functioning mood, I might go in and replace y with f of x. That would work as well. F of x in y's position. The graph of this thing. Now, parabolas have a very particular shape. They're sort of like the shape that you get if you have ever used a water fountain. If you've ever used a water fountain, then you'll see the water arc up into the air for a bit, and then gravity will take hold and the water will arc back down. And so this sort of arcing motion, up for a while, down for a while, is parabolic. Now, parabolas have a beautiful sort of symmetry to them. There's a very conspicuous maximum point on the parabola, a highest point, and if you draw a vertical line right through that highest point, then that vertical line will cut the graph perfectly into two equal pieces. And so that's the meaning of the term line of symmetry. A line of symmetry is a line that can cut a shape into two symmetric or identical pieces. Pieces with a C. All right, now I have drawn this particular parabola so that it has a highest point and it sort of cascades down from there. But a parabola may also be vertically flipped compared to this picture. It may also come down and open back upward. So from a lowest point, opening up. This is possible as well. This shape is also called parabola. And this shape can also be cut into two symmetric pieces with a vertical line right through this, in our case, this lowest point. Both these are parabolas. Now, we have some terminology to distinguish parabolas that look like this one from parabolas that look like this one. Parabolas are said to open downward if they look like the water from the water fountain. If they look like a frowny face. Both ends pointing downward. Whereas the parabola is said to open up if it looks more like a bowl or smiley face, both ends pointing upward. Now, one of the nice things about parabolas is it's actually very easy to tell from the equation whether the parabola will open upward or downward. If you have y equals ax squared plus bx plus c, if this fellow is in standard form, it's extremely easy to tell whether your parabola opens up like a smiley face or down like a frowny face. And it's all dependent on this leading coefficient, this number a. If a is positive, if your quadratic has a positive outlook on life, the parabola will have a smiley face shape and the parabola will open up. But if a is negative and your leader has a negative outlook on life, the parabola will have a frowny face shape and will open down. So that's it. If you want to know whether parabola opens upward or downward, all you have to do is check if A is positive or negative. Okay, so let's do an example here. Again, with a quadratic equation in standard form, y equals ax squared plus bx plus c. Now the question is, are there any features of the graph that you can figure out from standard form here without having to do any real math, any real calculations or number shuffling or quadratic formula or any of that? Well, one of the features that you can tell right away is you can tell whether the parabola opens up or down, because all you have to do is look at the value of A and say, is that positive or negative? You just have to look at A. No calculations required. But I claim that there's even a second graphical feature that you can detect without doing any calculations at all. I'd like you to imagine for a minute that someone asks you to calculate the Y-intercept. Now here's a review exercise. When someone says Y-intercept, that implies that who is equal to 0? Does that imply y is equal to 0 or x? Y-intercept, the opposite coordinate, x is 0, so that your point is on the y-axis. Now let's go into this equation and let's see what happens if x is 0. I have y equals a 0 squared b times 0 plus c. But the thing is that if you multiply anything by 0, a times 0 times 0, b times 0, those quantities all vanish. Gone, gone. And all that's left is this lone number here on the side. So the second graphical feature that you can detect right away from standard form is the value of the y-intercept. All you have to do is look at C. The C value is exactly where the y-intercept is located.